Hey guys, it's Justin back with an engineer's perspective, and today I wanted to do a somewhat quick video, hopefully. I've been thinking, so I've been messing around a lot with the different tool batteries, looking for kind of the best combinations of power and weight. So in 12 volt, whole package is smaller and lighter. How much power can you get out of it? And then the 18 volts, 20 volt max platform, you've got stuff like DeWalt's power stack, and then also like their compact series of batteries, which obviously are still quite large, but have the 21700 cells in them, giving them the higher power output. And just kind of thinking about all these things, these tool combinations that can be very light but still very powerful and have good longevity. And all of that culminated me wondering, does it make more sense to run an M12 tool on, say, like this XE 4.0, or gain a quarter of a pound and have this DeWalt power stack on the 887? So there's a quarter pound difference between, this package here, that's the Gen 3 Impact M12, and this package here. That's not a big difference, but theoretically, this power stack should last way less because it's only a 1.7 amp hours, which in an 18 volt pack comes out to about 31 watt hours of total energy in here, whereas this 4.0 should have 48 watt hours of energy in it. So it should last roughly 50% longer. So if you got 50 holes out of this one, you should get 75 out of this one. And so what I'm still trying to figure out in my brain is if the 12 volt versus 18 volt thing matters. My feelings is that it doesn't, but we will see. Theoretically, there's an amount of energy it takes to make that hole, and that's it. Doesn't matter what it's coming from, but there is efficiency that is going to affect those final results, and so we'll have to find out. And so what we're going to do is I'm actually going to stick those in some drill drivers, use this Diablo 3/4 inch spade bit here. I've got some very old stringers here that I tore out and we replaced in our house, and so I'm just going to drill as many holes as I can until the battery's dead, and hopefully that's enough wood. If not, we do have more wood available. Hopefully we don't get to that point. But I'm just going to start drilling holes with this. So the candidates for testing the batteries, we've got the Gen 3 Milwaukee drill here because I don't like spade bits and impacts. This is the 3404 with that 4 amp hour battery. Then, because it's the only 18 volt drill driver I've got, is the DCD 999 by DeWalt power stack in there. Both batteries are fresh off the charger. I'm gonna chuck that thing up and drill some holes and hopefully fast forward through that. So just give me a second, I'll get ready. All right, starting out with the DCD 999 power stack, full bars, 3/4 inch bit, speed 3, I'm sure it can do this, drill mode. All right, let's get to it. All right, I'm stopping the test there. That's the second hole it's failed on. If I let it sit for a second, it will finish it. So that's the number of holes we got. So showing the 1 bar, but that's enough. That was a lot of freaking holes. I'll count those up later. So next up is the Gen 3 M12 Milwaukee XE 4.0. Full battery. Just getting our bit. Set to drill, speed 2. Just mark. There it is, folks. It's dead. Okay, the results are in. First off, the power stack did amazing. Just hole after hole after hole. That went fantastic. The M12, it struggled really hard. Got through maybe the first 20 in speed 2 before it overheated. Flipped it down to speed 1. Got to maybe like 50, and then it was getting really hot, so I had to let it sit and cool down a couple of times. So that was a little bit of a battle, but keep in mind that all said, this was not a performance battle of speed or power. Not surprising that the M12 couldn't keep up with that level of task. You know, that's not surprising, totally fine. That in my mind, because there was quite a bit of heat buildup in the M12, that definitely is going to negatively affect its results. And the use case is more if you're using both of these over the whole day, not like that. How many holes or screws or whatever would you get out of a small 20 volt or 18 volt battery versus 12 volt tool? That does screw that up. But be that as it may, I think the results are still actually very clear. So I already kind of alluded to the numbers. We'll start with the M12. So on the Milwaukee's M12 XC 4.0 battery with 48 watt hours of claimed energy, we got a total of exactly 75 holes. Now with DeWalt Power Stack battery, 18 volts, claimed 30.6 watt hours, call it 31. We got a total of 97 holes. So there you go. My original hypothesis was that this battery, just based on total energy potential, would get about 50% more holes than the 18 volt pack would. But we conducted the test. I was curious, is there a difference in how those amps are being delivered with those voltages? All that good jazz, does it affect it? Definitely does. As I mentioned, the heat played a significant part of this, but we were nowhere near, we were exactly half of what this should have done compared to this. Could heat have that big of an effect? Maybe, but I think we can pretty safely say that you're not going to see the exact ratio. You know, if you've got 20 watt hours in an 18 volt and 40 watt hours in 12 volt, you're not going to get double the runtime. That's not how it's going to shake out. My guess, based on this, I mean, it's hard to say. It's hard to say what you will get based on this test because the heat came into it. But yeah, it's not the same. So we confirmed that. I think that is a huge selling point for this Power Stack battery. I actually drove over 400 screws. About half were 2-inch screws and the other half were about an inch and a quarter with this 887 on a fresh Power Stack, and it had 2 bars left. It's got legs, and it was just blistering that whole time, full on strength. So yeah, that's, I think, definitive that that is the case. So if you are on the DeWalt platform, and as more of these stacked lithium batteries come out, bringing this package into a size and weight class that is really starting to approach these 12 volt tools. I mean, this is obviously drill versus impact, but if you look at DeWalt's DCF 850, which is like the ultra short one, shorter than this M12, but the same weight. That tool is a 1/4 pound heavier than this package here. It will be shorter than this M12 is, while being about the same height and easily more powerful. And with the power stack, you're gonna get possibly more runtime than this 4.0 battery. It is a better package in every way. This doesn't make sense compared to a DCF 850 with a power stack, in my opinion. It's worth that 1/4 pound. So yeah, that's the test. That's all I've got. I hope you enjoyed. Have a good one. Bye.